All right, real quick before we get started, let's just do a factor review. So I'm going to give you just a second to solve the 3 problems on the screen, and then we'll go over them. All right, if you're continuing, then that means you've already finished the 3 problems on the screen. So let's start with the first one. We'll set up our factor x. We want to know 2 numbers that multiply together to give 36, add together to get 12. All right, that would appear to be 6 and a 6, and those are our factors. So we end up with x plus 6, x plus 6. All right, we could also say, if we wished, s plus 6, since they are the same term squared. For x squared plus 16. Well, I got an addition sign there, which means this is not difference of squares. So the only thing I can really do is look for the greatest common factor. Both of these terms are divisible by 4, so 4 would be my GCF. That leaves me with x squared plus 4. (18x to the 6th minus 50x to the 4th). Well, both of these are even numbers. They both have variables that have the same base. So let's go ahead and start with dividing out the 2x to the 4th and see what's left. That gives me 9x squared minus 25, where we'll realize, hey, this is a difference of squares. And since it's a difference of squares, we can take the square root of 9, which is 3, the square root of x squared, which is x, square root of 25, which is 5. We end up with our difference of square solutions, and we need to remember to bring down our first factor. Come on. So 2x to the 4th. And so our 3 factors are 2x to the 4th, 3x to the 5th, 3x plus 5, and 3x minus 5. Now, real quick, before we get too far into today, let's remember that we can FOIL. FOIL is first, outer, inner, and last. All right, x minus 3 means x minus 3 is getting multiplied by x minus 3. So we want our first, which is x squared, our outer, which is negative 3x, our inner, which is negative 3x, and our last, which is positive 9. All right. Let's pay attention real close to what's happening here. And let's see the relationship between the original problem. X squared, we ended up with x squared because both of our terms were just x. Negative 3 and negative 3. Notice, since both of my terms were negative 3s, they both produced a negative 3. When I add negative 3 and a negative 3 together, we get a negative 6x. So we have basically doubled that term, or that term. Plus 9. Well, where in the world did plus 9 came from? Well, negative 3 getting squared is going to give us a positive, so that's where we got the plus 9. What relationship do you see between the following? All right, we just discussed it on the previous slide. We see some correlation in where these values are coming. 6 is doubled. 36 is squared. Negative 6 is doubled. 9 is squared. So let's make all of these perfect trinomials. In order for them to be a perfect trinomial, notice that that had to be doubled. This value was squared. Well, what value did I double to get that value? That's right, we doubled a negative 5. So negative 5 squared is going to be 25. Just for kicks, let's go ahead and write this out as a set of factors. X minus 5 squared. See how quick and easy we could do that? All right, how about here? We have a positive 14, which means we started with a positive 7. Square positive 7, and we got 49. Again, just for kicks, x plus 7 squared. All right. Now those were easy. How about this one? What did we start with? We had to start with something that when it doubled, it became 11. Okay, how about 5.5? Now 5.5, remember, is the same thing as 11 over 2, because that's what we did. We just divided 11 by 2 and got 5.5. And remember, this term over here, whatever it is we're looking for, is half of this 11 squared. Now, is it going to be easier to square the 5.5 or easier to square the 11 halves? I think the 11 halves, because we square the top term, 121. We square the bottom term 4, and we're done. That's all we really need to be able to do at this point in time. Square the top term, square the bottom term. Now let's think about how would we write that as a factor. X plus, well, the square root of this term, well, that was 11 over 2. So completing the square, this is our focus for today. We want to move C to the right side of the equation. Move A and B to the left side of the equation. We're going to make a perfect trinomial square on the left. Now remember that anytime we solve equations, what we do to one side, we must do to the other. And that's the only way we keep our level balanced. If I add 2x's to this side, I have to add 2x's to this side. That keeps it balanced. Factor the left side. So we're going to simplify on the right. Factor the left, simplify on the right. Take the square root of both sides. Solve for x. Now, just like any time, getting a bunch of steps makes great sense. No, not really. Makes better sense when we actually practice it. So after you've written these down, move on to some practice problems, and we're going to move through these steps. So, solve by completing the square. We mentioned that we want the a and b on one side. We want the c on the other. So I'm going to add 6x to both sides of the equation, so that we end up with a and b on one side. X squared plus 6x equals 27. Mr. Gable, you made a mistake. You left a big old space there. No, I did make that mistake intentionally, because notice we're coming up on step 2 or 3 where we want to figure out the value of c to make a perfect trinomial. Well, what value of c makes a perfect trinomial? Half of b squared. Half of b is 3. Squared is 9. So we have added 9 to the left side of the equation. We must add 9 to the right side of the equation. I haven't really changed the value of this equation. We've just rearranged some numbers and added 9 to both sides to keep it balanced. Now notice on this side, we now have created a perfect trinomial, and that perfect trinomial can be simplified. Stated in terms of its factors. X plus 3 squared. All right, 27 plus 9, that's 36. And so we're going to take the square root of both sides. X plus 3 is equal to 6. Now, if you leave it just 6, your answer is going to be incorrect. Because remember, anytime we take the square root of an equation, we are talking about both the positive and negative roots. Anytime we take the square root of just 36, we're only talking about the positive principal root, which is just 6. A little bit of a difference in what we want for a solution. Now, if I have a plus or minus 6, that means the value on the right can be either positive 6 or negative 6. That means we're going to end up with two different solutions when we're solving for x. So let's subtract 3 from both sides. X is equal to, well, we can have a positive 6 minus 3, or we can have a negative 6 minus 3. Positive 6 minus 3 gives us a value of 3. Negative 6 minus 3 gives us a value of negative 9. So x can equal 3 or negative 9. Let's try again. Well, this particular problem we notice is already in ax squared plus bx, close to c, because c is on the other side. But notice all of these are multiples of 2, so what do we think we could do first? Yeah, that's right. We could divide the entire thing by 2. That's going to leave me with x squared plus 4x equals 12. And so now we want to find our differences squared, or sorry, our perfect trinomial. Half of 4 is 2. 2 squared is 4. So we're adding 4 to that side, adding 4 to this side. That'll give me 16 is equal to. Our perfect trinomial is going to be x plus 2 squared. We'll take the square root of both sides. X plus 2 is going to be equal to plus or minus 4. And so we'll subtract 2 from both sides, and x is equal to positive 4 minus 2 or negative 4 minus 2. 4 minus 2 is 2. Negative 4 minus 2 is negative 6. So our values of x can be 2 or negative 6. All right, question number 3. 4x squared plus 16x minus 1 is equal to 0. Now, we're going to multiply this entire equation by 1/4. Question is, why 1/4? Because we really want this leading term here to be 1, and the only way to make it 1 is to multiply it by 1/4. So, since we're multiplying everything by 1/4, we'll have 1/4 times 4 is 1x squared. 1/4 times 16 is 4. 1/4 times negative 1 is negative 1/4 equals 0. And so now we're going to solve just like normal. X squared plus 4x. We're going to subtract 1/4 to put it on the opposite side because we want that c term on the right side of the equals. So that'll give me 1/4. Sorry, we're going to add 1/4 because this is negative. So that'll give me 1/4 on the right side of the equals. Now we can say, okay, what's my b value? Half of that is 2. 2 squared is positive 4. So I have a perfect trinomial. Remember what we do to one side, we have to do the other side. So we're going to add 4 to that side. Now generally I would say, and I'm going to go ahead and say it before I even write the 4, I want to make an equivalent value to 4 that matches using the fraction denominator we need. So I need a denominator of 4. What numerator do I have to give this number here so that it simplifies to the solution 4 that we wanted to add to both sides? And that would be 16. All right, so let's clean things up a little bit. We have 1/4 plus 16/4 is 17/4 is equal to x plus 2 squared. And so we'll take the square root of both sides, and we're left with x plus 2 is equal to the square root of 17 over the square root of 4. We know the square root of 4, that is 2. So we have the square root of 17 over 2. All right, we want to take this and subtract 2 from both sides. And so we're going to end up with an x being equal to negative 2 plus or minus the square root of 17 over 2. Now, since 17 is a radical and it's not a perfect square, there's not going to be any way to simplify this much further. Yes, we could change the form and make it look different, but I am fine with a simplified solution just like that. All right, let's try another. X squared minus 5x plus 26 over 4. Now, I would be happy if you want to simplify 26 over 4, because that doesn't matter to me. So, x squared minus 5x plus something, because remember, we're going to subtract the 26 over 4 from both sides, equals negative 26 over 4, or negative 13 over 2. All right. Well, we want to take this term and cut it in half, so negative 2.5, and we want to square it. Well, it might actually be easier to deal with it as a fraction. Negative 5 over 2 squared. Well, negative 5 over 2 squared. Negative 5 times negative 5 is 25 over 4. Well, now you can see why the original problem started with 4, even though that could be simplified. So let's rewrite this. X squared minus 5x plus 25 over 4 equals, I'm going to go back to the negative 26 over 4, negative 26 over 4 plus 25 over 4. Notice I wanted to have the addition sign in both sides, or sorry, the 25 over 4 on both sides, so we kept the common denominator. All right. Let's make this a factor notation. So x minus 5 over 2 squared is equal to negative 26 plus 25 would give me negative 1/4. We're going to take the square root of both sides. All right, so we have x minus 5 halves is equal to the square root of negative 1, which we know we can't do, at least not with real numbers, over the square root of 4. The square root of 1 over the square root of 4, that's the same thing as saying square root of negative 1 over 2. So that rationalizes our denominator, which we like to see. And then we're going to add 5 over 2. We'll add 5 over 2. So x will be equal to 5 halves plus or minus the square root of negative 1 over 2. At some point in time, we'll continue to learn negative 1 is the same thing as I, so we're left with x is equal to 5 halves plus or minus I over 2, which is dealing with imaginary numbers, so I'm going to let you go ahead and leave your simplified answer like this. And since I is an imaginary number, what does that tell us about our solutions? We don't have any solutions. We'll get into more of that tomorrow.